All right, we're looking on page 278, 11-5, Quadrilaterals. We're going to be looking at the different properties of these many quadrilaterals, so you'll want to pause me when you need to and take notes. So it starts off with the question, what are the properties of different quadrilaterals? All right, so to start, know that any quadrilateral could be divided into two triangles. All right, and since we know the sum of the measures of the angles in each triangle is 180 degrees, right? Every triangle's angles measure up to or add up to 180 degrees, then the sum of the measures of the angles of any quadrilateral is going to be 360. So here's a trapezoid, for example, up here. And they show you that, well, we can just draw a diagonal line, and we have now two triangles. And we have each triangle would have 180 degrees in these angles, but we have two of them, so you add that up and you're going to get 360 degrees. Now trapezoid, here are your properties of the trapezoid, is a quadrilateral with only one pair of parallel sides. So I've written all over this, but for example, this trapezoid here has this side, I should make that, and this side that are parallel. Lines would never intersect. Let's look at some others on the next page. All right, look on page 279, and we're looking at here a parallelogram. A parallelogram now is also a quadrilateral with both pairs of opposite sides parallel. So here this side and this side are parallel. This side and this side are parallel, which is probably why it's called a parallelogram. Also, parallelograms' opposite sides are congruent. So if I look at this side, you can see I have two hash marks, and the opposite side has two hash marks. That means these two sides are the same length, along with these opposite sides here are the same length, which is why this one only gets one hash mark, this one gets one hash mark to say these two are congruent, where these two get two. And also, opposite angles are congruent. So you can see that this obtuse angle is congruent to this opposite obtuse angle, whereas these acute angles, opposite angles, are congruent. Same measure, okay, same angle. A rhombus is a parallelogram with all sides congruent. So it has all of this that's going on up here. We have opposite sides parallel, opposite sides parallel, opposite angles congruent, opposite angles here congruent. The difference is, an added property is that all sides are the same length, which is why they all have that one hash mark, because all sides are congruent, are the same length. Okay, last but not least, we have a rectangle and a square. A rectangle is also a parallelogram. It can be classified as a parallelogram with four right angles, because again, opposite sides are parallel here, right? And this side, opposite side are parallel. They also have opposite sides congruent. This side is as long as the opposite side, and here this side is opposite side is congruent. Opposite angles, here we go, are congruent also because they're 90-degree angles. It has four right angles. So again, this side and this side are going to be congruent. Actually, all angles, are congruent because they're all right angles or 90-degree angles. A square is a rectangle, which is also a parallelogram, right? But it's a special rectangle because all sides are congruent. So, and also know a square is also a rhombus, because if you look at the properties, a square also has all the properties of a rhombus. So it can be classified as a rectangle, a rhombus, a parallelogram, because it has opposite sides parallel, opposite sides congruent, all sides really congruent, opposite angles congruent, so it fits all those properties. All right, let's look back on page 278. Let's look at another example here on page 278. It says, how can you draw, okay, you've drawn a triangle, now it wants you to draw a quadrilateral from the information that's given. So suppose you want to draw a parallelogram with 5 centimeter and a 2 centimeter side. The measures of the opposite angles are 135 degrees and 45 degrees. Now remember, parallelogram, opposite sides are congruent, so you know you're going to have two sides that are 5 centimeters, two sides that are 2 centimeters, and then opposite angles that are 135 and opposite angles that are 45 degrees. So the first step, they say, is go ahead and draw your 5 centimeter line segment, like here. Then draw a 45 degree angle at one end, here, and you know that the opposite side would be 45, so that leaves 135 for this other bottom right side angle. So they go ahead and draw it here 2 centimeters on this side, and this side has to be exactly 2 centimeters also. Once you get that done and you put your little endpoints on there, all you have to do is then connect the two sides with the line segment. And you want to check that the last side actually measures 5 centimeters. This is a little tricky, but we'll practice at school. And in the last step, it's just showing you that the sum of the measures of all these angles is going to total 360 degrees like we showed above, because the parallelogram can be divided into two triangles. But if you add up 45, 135, 45, and 135 again, you'll get 365 or 60 degrees. Okay, the rest of your homework is to do the guided practice on page 279, 1 through 4. It's first, classify each polygon in as many ways as possible. Sometimes there's only one way to classify it, and sometimes there's 4 ways. So make sure you do it as many ways as possible and find the missing angle measurement. Okay, and then go ahead and answer questions 5 and 6 and bring it tomorrow to class with a question. See you then.